we have to see the electronic configuration of an atom. Already we see in Bohr's model energy levels and orbits. Why we are saying that orbits and energy levels, that is electron distribution path is known as energy levels or orbits. So the distribution of electron in different cells is called electronic configuration. This distribution of electrons is governed by certain rules of or conditions known as Bohr's or Bury rules of electronic configuration. See how it will be presented. First rule, it will be, see, the maximum number of electron that can be accommodated by in these cells is given by 2n squared formula. Already I told the last video, 2n squared formula. The n is equal to number of cells. If first cell, K cell, so n is equal to 1 means how many electrons will be formed? Equal to 2 into 1 square equal to 2 electrons. See here, K cell they written as 1 into 1 square is equal to 2. So first rule, how many electrons, the maximum number of electrons that can be accommodated in these cells, you must identify. Okay, next, cells are filled in stepwise manner in the increasing order of energy. After this one, I say how the energy levels will be filled. The cells will be filled. Okay, the outermost cell of an atom cannot have more than 8 electrons. So 8 electrons is a stable electrons. Even if it has capacity to accommodate more electrons. For example, you take electronic configuration arrangement in calcium having 20 electrons, that is atomic number is 20. You have to split this. First you have to split the K cell contains, see here, K cell contains, you know very well, 2 electrons. Out of 20, 2 is subtracted. Okay, after that L cell always contains 8 electrons. After that 8 also you subtract. Totally 10 electrons. After that M cell equal to that also contains 8 electrons. So 8, it contains 18 electrons, but 8 only it will be filled. I say how it will be filled. Okay, totally how many electrons? 18 electrons will be completed. After it goes to N cell equal to 2. How it will be filling? I am saying. Okay. So K cell contains 2 electrons, L cell contains 8, M cell contains 8 electrons and N cell contains 2 electrons. Suppose below that one we have arranged here itself. Okay, these are the 3 rules. First you have to know the maximum number of electrons that are accommodated in the cells. After that, stepwise manner increasing order energy. After that, 8 electron will be the stable. Outermost cell contains 8 electron is the stable. Remaining electron goes to the next cell. That will be seeing the next part. Okay, see here. You know very well what is the electronic configuration of aluminium. Aluminium contains atomic number 13. Aluminium atomic number 13, 1, 3. Okay, here see. Electronic configuration of aluminium. First you have to filled in the K cell. K cell contains how many electrons? 2 electrons. Next M cell. M cell contains 8 electrons. Totally how many electrons completed? 10 electrons completed. So K, L next. Okay, sorry. L next. Next M. M is equal to remaining 3 electrons. So outermost cell contains 3 electrons. So its electronic configuration is 2, 8, 3. Okay. The force between the proton and the neutrons in the nucleus are special kind called Yohova forces. This strong forces is more powerful than gravity. Okay. Next you see, I am saying no, how it will be filling. This is known as the first cell contains. See here, you know very well K cell. K cell is the first cell, that is 1. So this cell contains 1s orbital. 1s orbital. The s orbital always contains 2 electrons. So it contains 1s 2. Okay. Next L cell. L cell contains 2 orbitals, that is S, P. S always contains how many electrons? 2 electrons. P always contains 6 electrons. So 2 plus 6 equal to 8 electrons. So L contains how many electrons? 8 electrons. Okay, this one will be filled like that. So each and every cells, how it will be filling, I say. Okay, next D orbital, it contains 10 electrons, and F it contains 14 electrons. This is the rules. Okay, next you see the first cell contains 2 electrons, second cell contains 2 electrons. You write like this shape, 1s2. See here, 1s 2, 2s 2, 2p 2, 2p6. Okay, 3s 2, 3p 6, 3d 10, like this. First you have to draw a line like this. See here, this like only it will be filled. First it goes to 1s, second it goes to 2s, third it goes to 2p after 3s. Okay, next it goes to, see here, 4s you can write here, no, it will be comes like this, the line. So 3p6 filled after it goes to 4p. After that only it goes to 3d. 4p6 after only it will be goes to, so it will be comes like this. So 5s here, 5s2. Okay, first 5s2 after 4p6 after 3d10. Next only it will be filled like this only it will be filled from up to down. Okay, I given here, see, n is equal to 1. Like this only it will be filling. First 1s. Like this it will be going on. Next 2s. Next 2p after 3s. Next 3p after 4s. Next 3d 4p after 5s. Next 4d 5p and 6s. Next 4f 5d 6p and 7s. Like that it will be going on. This is the filling manner of the electron in a cells. Okay, this is I given here in an atomic physics and quantum chemistry. The electronic configuration is distribution of electron of an atom or a molecule in an atomic or molecular orbits. For example, you take the electronic configuration of neon atom. Neon. Okay, neon 1s2. So, neon is equal to 10. Neon atomic number 10. So you have to write it as 1s2. From this manner I am saying 2s2 after 2p 6. Totally how many electrons? See here, 10 electrons, 2 comma 2 comma 6. So 1s2, 2s2, 2p6. This manner only it will be filling. Okay, next you see, these are the energy levels. First energy, second energy level, third energy level, K, L, M, N, like that. How it will be filling? See here, nucleus. K cell contains 2 electrons, 8 electrons, 18 electrons, like that. So, outermost contains always 8 electron. Okay, you see here, here also I given how many electrons will be, maximum electron must be filled. In your element, atomic number wise, you have to fill like the quantum number, quantum theory. Okay. See here also K cell, M cell, N cells I will be given. So in geometrical, the structure of an element, knowing the mass number and the atomic number of an element, we can represent the atomic structure. How it will be presented? See here, geometrical represents of oxygen atom is like this. You have to write here 16, 8. What is this one? This is the superscript. Superscript is mass number and the subscript is atomic number. Atomic number consists of proton or electron. Mass number consists of neutron and proton. Neutron and proton. Okay, next, mass number is equal to denoted in A. Already last video we see A is equal to 16. Atomic number Z, it will be denoted in Z, equal to 8. Number of neutron A is equal to A minus Z is equal to 8. Number of proton and number of electron. Electronic configuration, how will you write? See here, electronic configuration, you take the atomic number. Atomic number is 8. You have to written as 1s2, 2s2, 2p4. So 2, 6 you can write like this, because these twos are separate cells. This is K cell, this is L cell, this is K cell, this is K cell, and this is L cell. So we have to write 2, 6. So electronic configuration is 2, 6. That will be written in a dotted structure like this. See here, dotted structure. This is a nucleus. The first cell I am drawing, and this second cell. See here, second cell. Okay, first cell contains 2 electron. Here one electron and here one electron. Okay. Next, second cell contains how many electrons? 6 electrons. So here 2, here 2, here 2. Wherever you have to place in the second cell. So 6 plus 2, 8 electrons. So you have to write it as 2, 6. Totally 8 electron. This is the oxygen atom electronic configuration. I will give more example for you. See here, sodium atom. Sodium atomic number. See, sodium atomic number. You have to count. First cell contains how many electrons? See here, first cell contains 2 electrons. Second cell contains, see here, 1, 2, 3, 4, 5, 6, 7, 8, 8. Next, third cell contains 1. So you have to write this one, 1s2. See here, 1s2, 2s2, 2p6. After that, 3s1. This one lay electronic configuration of sodium. 2, 8, 1. Atomic number, how will you calculate? 2 plus 8 plus 1, how much? 11. So sodium atomic number is 11. That is 11 electron and 11 proton. Okay, see here, next also helium I given here. Helium consists of 2 electrons. So first cell contains 2 electrons, that is 1s2. That's all. Okay, next you see here sodium. You have to write this, not only dotted structure, you have to write it as into mark also. You have to denote you have denoted as a dotted structure or into mark for electronic configuration. Okay, next you see magnesium. Magnesium, you have to count it. First cell contains 2 electrons, second cell contains 1, 2, 3, 4, 5, 6, 7, 8, and third cell contains 2 electrons. So the atomic number of magnesium is 12. So atomic number of magnesium is 12. How will you write? 1s2, 2s2, 2p6, 12. So 3s2. Like this only it will be coming. So 2, 8, 2. The outer cell contains 2 electrons. Okay, next you see lithium. Lithium, how many electrons are there? 3 electrons. So lithium, having atomic number 3. See here, lithium having atomic number 3. Lithium having atomic number 3. 1s2, 2s1. See here, how many electrons in the first cell? 2 electrons. Second cell contains 1 electron. So outermost cell contains only 1 electrons. From this we have to calculate the valency. So only I am saying outermost cells contains how many electrons. Okay, next you see sodium also, magnesium, lithium. Okay, next how many electrons are accommodated in each and every cells is given in your table. K cell contains n is equal to 1, so 2 into 1 squared equal to 2. Like that I calculated all those first 4 cells. You have to calculate again and again. K, L, M, N, O, P, Q, R, like that. Okay, students, today's session will be over. Tomorrow